Next presenter. The next presentation is called NetMeta, a scalable network observability toolkit optimized for performance. And the presenter is Tim Windelschmidt. Tim is working at Monogon SE as a systems engineer, and in his free time, he mostly writes high-performance tools in Go to create an open-source DDoS mitigation tools. Tim, the floor is yours.
Thank you. First of all, my name is Tim. As already said, I work at Monogon and one of the maintainers of NetMeta. I will talk fairly quickly this talk because I have a lot of slides and a lot of things I want to talk about. So if you have any questions, you can contact me over Telegram or GitHub or anything. I'm always happy to help. First of all, what is NetMeta? As already said, it's a scalable network observability toolkit optimized for performance, but what does this mean? It's basically just a flow collector, but completely open source and permissively licensed. It's based on ClickHouse and allows fairly easy use of literally everything that writes SFlow, NetFlow, or whatever. It also has support for the use of port mirrors, but that's something we'll come to. Why another flow aggregator is fairly easy. Other ones just got abandoned, like the fairly used elastic flow, but there is another one, but that's closed source. They didn't have the same performance, or they were just too expensive. As already said, Elasticflow 2 is closed source. There's Kentic, but fairly far away for most people because it's way too expensive. Akvarado didn't exist at that time when NetMeta was created, so that also fell out, and there are no support contracts. And for some people, it's also important to mention it's HTTP/LV3. That's not always a problem, but sometimes if you want to give your customer access or something like that, that can create problems. NetMeta is completely based on Grafana, so it's just supports everything that you already have. You can just import it in your existing Grafana infrastructure. It supports fastedmon attack notifications by just connecting the InfluxDB, but also you can just use fastedmon as your data source. If you don't have flow data, but you have fastedmon in your infrastructure, you can just say you want to use the fastedmon data, then it will use the same already existing graphs in Grafana. The data flow is fairly simple. I will go through it. This is not the up-to-date version of the slides, but that happens. So first of all, we're using GoFlow and GoFlow v2 as a flow collector. It is fairly compatible with nearly everything. We are planning an agent which is based on the Linux TC, so you can use it on all your infrastructure and all your servers. And as I already said, there's a port mirror. When you have a fiber tap environment, or you can't use SFlow data because your routers don't have that in hardware, you can just set up a secondary box where you fiber tap in your existing infrastructure and generate samples out of that. Everything is then sent to a Kafka database, or not Kafka queue, so that even in the case of your collector is crashing or your database you're getting DOSed and your database is overwhelmed with the data, you don't have any data loss. You can scale Kafka fairly easy and also have complicated setups by setting up multiple Kafka queues on all your POPs and then feed that into a central database so you have always all the data. The heart of the software is ClickHouse, as lots of other flow collectors that are currently out there, like Akvarado, we are using ClickHouse. But instead of having external tools that are aggregating the data, everything is in ClickHouse. NetMeta is, how I mostly call it, a glorified SQL generator, because everything is done in real time. If you ingest data, it will just create a protobuf data, which is then ingested into ClickHouse. And then everything you see on the dashboard is just in real time selected, and you will have fairly easy solution to search for everything because you can just extend the SQL. The funny thing about clickers is it supports the weirdest features from reverse DNS directly as a function inside your SQL to per column compression, which allows you to have very, very good compression. As example, when you have like 17 billion flows in your database, it's just 400 gigabytes. But as you can see on the slide too, if you have less rows, it doesn't compress linearly. It just takes some time until like ZSCD or whatever you want to use kicks in and actually compresses fairly well. Then back to Grafana. Everything you see in NetMeta will be just a Grafana dashboard. We built, we deploy our own Grafana, but you can also dump your dashboards and import it in your own infrastructure, so you don't want to have multiple Grafana instances. For every tool that uses Grafana, you can just import it. And nearly everyone has their own Grafana instance anyway, so that's a good thing to build on. It's easy to extend, as you can just import everything that has Grafana support. When you have your own annotation provider, you can just use it. Deployment runs completely on Q and Bazel. So Q is a configuration language which is like JSON, but it has some additional things. You can maybe, if you heard of KCL, which is another thing, it's basically just JSON. It generates everything from the Grafana dashboards to the Kubernetes manifests because the whole system is based on K3s currently. All the containers, like the reconciler for the SQL tables and sources for like BGP data, are generated with Bazel, and everything is based on the protobuf files. So there's everything which you have in NetMeta is just based on static files in the repository. When you change something, you can just say, I want to redeploy, and everything is rebuilt based on these configs. So you don't have any different state between your infrastructure and your configuration tools. As I already said, currently it's using single node for single node environment, just K3s on a single node. But you can do multi-node deployments, which you would have to do yourself right now because there is no official way for generating the configs. This is based on the issue that when you generate these configs, they're on your local machine, and then you have to generate configs for every machine, and that's a fairly complicated way to complicated to configure. So that's currently not done. And there's work on the native NixOS deployment, so if you have NixOS in your infrastructure, you can just import this as your flake and set some config values, and everything should just work. What else to come? We are currently, as I said, working on an agent and multi-node deployments. We want to support AS paths via BMP, so you can also ingest your BMP data. Reverse DNS is kind of tricky because even though ClickHouse has a support for it, you don't want to run reverse DNS every time you do a select. You want to cache it, but then you don't want to cache it too much. Additionally, GeoIP or whatever you want, because it's fairly easy to extend. And if you have any feature requests, just open an issue. I'm happy to help. And yeah, that's it.
Thank you, Tim. Are there any, actually we do have time for questions. Are there any questions? Nothing on the chat, nothing in the room? Hey, come on. Okay. Thank you, Tim.
Thank you.